So hi everyone, my name is Shivam Bohra. Welcome to the official channel of CodeChef. So if you want to learn and master data structures and algorithms, or if you want to do really good at competitive programming, then this is a one-stop destination for you. Now before we actually get started, here's a quick reminder for you to hit that subscribe button if you haven't already yet. So now let's move on to the next problem. So the problem statement says that given n numbers a1, a2 and so on till an and a number x, print yes if the sum of any two numbers at distinct positions in this array is x, otherwise print no, right? So it basically means that we have some numbers in this array. We have to choose two numbers, two numbers at distinct positions in this array such that the sum of these two numbers is x, right? For example, if let's say my array has four numbers 1, 3, 5 and 7, and let's say x is 6, right? So in this case, we can see that on adding this 1 with this 5, on adding 1 with 5, I'll get 6. So it is possible to take out two numbers from this array such that the sum of these two numbers is x, So hence I'll print yes in this case. But if let's say my x was 7, then over here there are no two numbers such that the sum of those two numbers is 7, right? So in this case we have to print no. So the constraints over here are very similar to the previous one. Again, the maximum value of n is 10 to the power 5. So again, n square approach would not be acceptable, right? So now let's move on to the approach. So we are not allowed to have an approach which works in big of n square time complexity. So let's try to derive an approach which would solve this problem in a time complexity much better than big of n square, right? So I can sort this array because sorting takes n log n, big of n log n. So I'll sort this array and I'll have these 5 array elements in sorted order. And now what I would do is I would try to remove elements from this array. I would try to remove elements from this array such that those elements are not capable enough of making a sum x, right? Or making a sum 12 in this case, right? So I'll point to the very first element and the very last element. Now one out of these two elements would not make any sense, right? One out of these two elements would not make any sense. Let's understand how. So we have a 1 over here and a 9 over here. 1 plus 9 equals to 10, right? So the sum over here is 10. So we are supposed to have a sum 12, but we are having a sum 10. So this 1, if I add this 1 with the largest element of this array, then also I'm not able to make my sum 12, right? Or I'm not able to get a sum 12, right? I'm getting a sum lesser than 12. So this one, on adding with the largest element of this array, is not able to make a sum x. Hence, if I add this one with the rest of the array elements, I'll get a sum lesser than 10, right? I'll get a sum lesser than 10. So this means that this one is not capable enough of making a sum x, right? This one is not capable enough of making a sum x. Hence, I'll simply discard this element. And now I'll move on to the next element. So now we have 2 and 9, right? Again, 2 plus 9 equals to 11. 11 is again smaller than 12, right? So this means that this 2 is again not capable enough of making a sum 12, because if I add this 2 with the largest element, I'm getting a sum lesser than 12. Hence, if I add this 2 with the rest of the array elements, I'll get a sum even lesser than 11, right? So again, I'll discard this 2 and now I'll move on to this 5, right? So now we have two elements 5 and 9, right? So now we have this 5 and 9, right? So let's see whether these two are able to make the sum 12 or not. So I'll add 5 with 9. So 5 plus 9 equals to 14. So now the sum is 14, right? 14 is more than 12. Hence, this time, one out of these two would again not make any sense, right? So let's see whether this 5 makes any sense or not. So on adding 5 with 9, I'm getting 14. If I add 5 with another number inside this array, I'll get a sum lesser than this 14, right? So 12 is lesser than this 14, so this might work, right? So if I add this 5 with 7, 5 with 7, I will get 12, right? So 5 makes sense over here. But let's see whether this 9 makes any sense or not. So we have 9. If on adding 9 with 5, I'm able to make a sum 14. But what if I add 9 with any other element inside this array? So this would increase my sum. This would increase my sum. You can see that 7 on adding with 9 would fetch me 16. So on adding 9 with any other element inside this array would increase my sum. Hence this time 9 will not make any sense. So now I'm down to these two elements 5 and 7, right? 5 and 7. So 5 plus 7 is 12. So now the sum is 12. 12 is exactly what we want. So we would print yes in this particular case. So this was the proof of why this method actually works. So let me quickly summarize it for you. We have two pointers, one pointing at this location and one pointing at this location. Let's call the first one I and the second one j. Now, the sum initially is 1 plus 9, which is 10. So the sum is initially 10. So if the sum is not equal to x, then automatically one out of these two numbers would not make any sense, right? So over here, I want to increase my sum. I want to increase this 10 to make it 12. So this element pointed by this j, it is already the largest element of this array. So I cannot increase the element pointed by this j. Hence, the only way to increase this sum is to increase the element pointed by this I. So if sum is less than x, if sum is less than x, then the only way to increase this sum is move I to the next location. So I equals to I plus 1, right? So now I'll discard this element and now my I would point to this element 2, right? Again, 2 plus 9 equals to 11. So again the sum is lesser than 12. So again sum is less than 12. Hence I'll move I to its next position, right? So again I'll discard this element and I'll move I to the next element. So now I will point to this 5. So 5 plus 9 equals to 14. 5 plus 9 equals to 14. Now 14 is the sum. Sum is greater than this 12. So now I want to decrease the sum, right? So I want to decrease this sum. So this element pointed by this I cannot decrement this element, or I cannot move I back to its previous position because I have already discarded these two elements. So the only way to decrease the sum is change the value of j, because if I move j over here, then now the element pointed by this j has been reduced. So this would increase the chances of making this sum equals to this 12, right? So if sum is greater than x, then the only way to decrease the sum is change the value of j. So j should be j minus 1, right? Move this j back over here, right? Now let's say x is 13. Now let's see whether we are able to make a sum 13 out of this array or not. So I would be pointing here and j would be pointing here. 1 and 9. 1 plus 9 is 10. So the sum is initially 10. 10 is smaller than x, right? Or 10 is smaller than 13. So the sum is smaller than x. So if sum is lesser than x, then increment the value of I, right? So I'll move I over here and I'll discard this one. So now we have 2 and 9. 2 and 9 is 11. So we have 11 over here. Again, the sum is smaller than x. So again, the sum is less than x. So again, I'll increment the value of I. So I'll discard this and again, I'll move I to the next element. So now we have 5 and 9. 5 and 9 is 14. So this time 14 is greater than x, or sum is greater than x, right? 14 is greater than 13. So if sum is greater than x, then change the value of j to j minus 1, right? Or simply move j to its previous element. So now j would point to this element and I'll discard this element. So now we have 5 and 7, right? So this time the sum would be 5 and 7, which is 12, right? So this time the sum is 12. Again, the sum is smaller than x. Again, 12 is smaller than 13. So again, sum is smaller than x. So if sum is smaller than x, if sum is less than x, increment the value of I, right? So I'll discard this one and I'll move I over here, right? Now at this point, I and j are pointing to the very same element, right? But we have to choose two elements from this array at distinct positions, right? From distinct positions. So this means that if our I and j are colliding, then we have to stop. And in this case, we will print no, right? So now let's move on to the code. So firstly, I'll input n and x. Then I'll create an array of size n. I'll create an array or a vector of size n. And I'll simply store all the array elements inside this vector, right? Then I'll simply sort this vector. And then I'll create three variables. I would point to the very first location, j would point to the very last location, and f is a flag variable whose value is initialized by 0, right? This 0 over here means that we haven't found such a pair whose sum is x, right? So if I find a pair whose sum is x, then I'll later change this value from 0 to 1. Then I'll simply check whether while I not equals to j, right? This means that I and j should not be pointing at the very same element. Then I'll simply find the sum of ARR of I and ARR of j, initially the very first and the very last element. I'll check if this sum is equals to x or not. So if the sum is equals to x, then we have found our pair. I'll change the value of f to 1 and I'll simply break this loop, right? If sum is lesser than x, then I'll move I to the next element. If sum is greater than x, then I'll move j to its previous element, right? And after this loop, I'll simply check if f equals to 1 or not. If f is 1, then I'll simply print yes, we have found such a pair, else I'll print no, right? So this is the input. This is the exact same array and we are searching for a sum 12, right? So if I run this code, then we have 5 and 7 over here, which make a sum 12. So this should print yes, right? And similarly, if I search for 13, then they should print no in this case, right? So here we can see that it has printed no. So that is it for this video. Like if you understood the concept. In case of any doubts or feedback, do leave them in the comment section below. Subscribe to our channel and press the bell icon to get notified about our upcoming uploads. You can also join our Telegram group. The link is in the description and I'll see you in the next one.